Welcome to Saxon Math Course 3, Lesson 16. Today we're talking about irrational numbers. Our objectives for today, after this lesson, you should be able to approximate the value of square roots with and without a calculator, identify numbers as members of the sets of irrational numbers and real numbers, and compare and order rational and irrational numbers. And also find the length of a side of a square when you're only given the area. Review from last time, we talked about powers, which is just repeated multiplication. Remember that raised number tells you how many times you're going to multiply that same number. We also talked about roots, which are really the opposite of powers, and that's figuring out which repeated number multiplied will give you that total. And the last thing we talked about was perfect squares. And those are squares of whole numbers, 1 times 1, 2 times 2, 3 times 3. So today we're going to talk about irrational numbers. So sometimes when you do the square root of a number, a whole number, you get a decimal answer that goes on forever, but it doesn't repeat. That's an irrational number. When we have numbers like that, the best thing we can do really without a calculator is to get a general idea of where that number would be on a number line. Which whole numbers would it be in between? So for example, between which two numbers on a number line is the square root of 5? I know I can't do the square root of 5 because there is no number that you multiply times itself to get 5. So I go with what I know. I know the square root of 4 is 2, and the square root of 9 is 3, and 5 is in between 4 and 9. So square root of 5 has to be somewhere on a number line between the whole numbers 2 and 3. And if I want to be even more specific, 5 is much closer to 4 than it is to 9. So it's probably somewhere between 2 and 2.5. On that side of being between 2 and 3. Closer, definitely closer to 2 than it is to 3. We can also use a calculator to find unknown square roots. If you put in the square root of 5 in a calculator, you actually end up with, and I'm doing it right now, you actually end up with, and I'll read everything that shows up on my calculator here. So you end up with 2.236067977499979, and it would just keep going on and on, but the calculator only shows so many numbers. So it was definitely closer to 2 than it was to 3. When you put those two sets together, so we talked about rational numbers before, that's anything that could be written as a fraction. So that's all whole numbers, all integers with the negative numbers, that's all fractions and non-repeating decimals, or even some repeating decimals, I should say. Irrational numbers are what we just talked about, decimals that go on forever but they don't repeat. All those together make the set of real numbers, and we're not going to talk about the other set of numbers. You'll talk about those in high school. There are numbers that are called imaginary numbers, believe it or not, in math. So real numbers is about as far as we go with sets of numbers. We can approximate the value of irrational numbers in order to order groups of real numbers. So for example, this looks kind of crazy, but if we have the numbers 2, square root of 5, 5/9, 0, 3, 1 2/10, and 1, and we want to put them in order from least to greatest, we're going to first figure out what we know about each of these numbers. Since there are no negative numbers on this list, I know that 0 is going to be my least. So that one's easy. Then I go with what I learned just a little bit before in this video. Square root of 4 is 2, square root of 9 is 3, and so the square root of 5 is between 2 and 3. It's less than 3, but it's more than 2. 5/9 I know is less than 1, because if it were equal to 1 it would be 9/9, and I know 1 2/10 is more than 1. So using all of that stuff that I just figured out about these numbers, this is my order: 0, 5/9, 1, 1 2/10, 2, square root of 5, and 3. So it can look kind of difficult, but you just have to work through it logically and kind of mark down what you know so that you can figure out the order they should be in. The last thing we're going to talk about is finding the sides of a square. Remember, a square has sides that are all the same. So when you find the area of a square, really what you're doing is you're squaring that side length. So in order to go backwards, you have to square root the area. That will give you the length of each side. So for example, if we had a square that has an area of 6 meters, what is the length of each side? You don't actually have to try to figure out what the square root of 6 is, because that, I mean, without a calculator, you're not really going to be able to do that. So you just leave it as the square root of 6. So the length of each side would be the square root of 6. So if you drew that square, so here's my square, and I want to mark the length of the side, I would just put square root of 6 meters, and that's it. Just a note, that is an actual length, though. It's not a made-up number. If you do that on a calculator, that's about 2.45 meters. I just rounded it to the nearest hundredth, so 2 45/100 meters. That's all for today's lesson. Make sure you do your practice problems, post any questions you have so we can discuss them, and we'll see you in the next video.